What's going on here, guys? I cleaned up the setup a little bit, and I figured I'd do a video response to a lot of people telling me that there's nothing special about the fact that this pulsed output can rapidly recharge a big capacitor bank or battery that then ran this inverter to run a load. Well, no, those people are completely wrong and incorrect because, again, our circuit is on and that's the input to it. Hardly drawing any power. That's like 50 milliamps we're drawing. Anyway, the circuit's input draws less than 2 watts. And our high frequency, first of all, that 2 watt input, less than 2 watt, goes into the pulsar circuit. And that high frequency gets rectified to DC. We're almost using electrostatics here. So we're using a very high frequency, we're turning it to DC via this rectifier here, and we very rapidly recharge this big capacitor bank. And I'm going to touch this and even lift it, which you shouldn't do. Show you there's nothing underneath it. There's nothing in this box, it's just a support. It just sits on that. I shouldn't even be touching this thing when the circuit's on, it's dangerous. So, again, sum it up. Input less than 50 milliamps, less than 2 watts, powers up the ringer circuit. Ringer circuit goes through a rectifier. We're using just the voltage alone to rapidly recharge our cap bank, and then we take that power, send it through a timer circuit and a DC to DC converter that steps it down from 50 volts to 14 volts. That can then run a pulsed load, high amperage pulsed load, and we will see that there is no degradation when we run that pulse. So there's no, right now we're going to take that pulse power and power up a little light bulb here. So he's a 12 volt 5 watt, I believe. I can't even see what that is, but anyway, I'll hook that up to our pulsed output of the circuit, and you will see that that pulse when that pulse fires, it does not affect our input in any way. So there's the free energy aspect. I don't know how much more cleaner the system can be. And now you take that pulsed output and you dump it into a large supercap or a battery. So that's the raw output of the pulse from those capacitors, the timed pulse. Running a light bulb. The light bulb looks like it almost wants to burst. So it's absolutely an over unity pulse. When you deal with the time factor, this output pulse will give you far more output power over time than the input draw to the circuit. And again, that's our input draw. And for those who say this analog meter doesn't work and isn't displaying properly, well, no, I will change my parameters here. I'm adjusting the timing of my circuit to something very long, and we will see it drain. Okay, that's set. And we should be good. So now we're eventually going to run this too long and drain the input, as you see. We screwed up the timing, kind of like when an engine doesn't run right. We screwed up the timing and the circuit is now out of tune, and we have a very big draw on the input. See? I screwed up the timing now. And now we are draining the source a lot more rapidly. This is not over unity now. And you can hear it really whining and kicking on the circuit. So again, I will set the parameters back to what they used to be. and the system will accumulate a full charge. Let's say 0.1 second pulse of very high current. And I'll wait a little bit before I turn it on because I want the system to accumulate a charge without affecting my input. I'll wait 20 seconds. 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We are now back on normal. We are firing at the correct frequency, high amperage pulse. And that will not affect our input now because the timing is correct. And again, we're at an over unity stage now. This can fire all day long without ever draining the input. This is what's recharging our other large capacitor bank, or our other large super cap, very rapidly. That then ran this inverter. There's the bulb. So you're seeing everything here. I cleaned the setup. Here's what the timing circuit looks like. There's no magic to it, just electrical engineering. We're not even using the last stage of this, which we would connect this to the last super cap and then connect the inverter to that. So you're seeing that right there. No effect on the input. And I proved in this video the analog meter works fine. Just more in frame. So that is a, what do we have, a 50 milliamp draw? Either 50 or 100 milliamp draw. We ain't even twitching the input. So that's how fine-tuned it is, the pulsing. Rock steady on the input. The timing has been corrected, and we still have radiant energy output too from this thing. It even accumulates in the capacitors, which is nuts. So you don't want to touch that terminal to terminal. There's about 50 or 60 volts DC in there. So this video should silence a lot of skeptics that the pulsing in the timing circuitry section is completely solved. So yeah, showing everything off. There's no form of power up here except the input caps that are running it, so it's generating its own power from the system. Technically, the correct thing to say would be it's extracting wireless power from the material it's wound on, because this is technically a high frequency transformer that's wound on a nano crystalline ferrite rod laced with powdered metglas. You can kind of see it shining a bit. You can order these from China, Alibaba, a bunch of different various companies. I have a small stockpile. If anyone wants to buy from me, it'll be a lot quicker than waiting to get it from overseas. So yeah, anyone wants to buy them, just hit me up or email me. So technically this is the power source for the device. The device is extracting more power from this via the environment. A negative resistance effect occurs, and this rod is sucking in more power from the environment via negative resistance and the exotic material it's made out of. It rings a lot too if you hit it just right. And again, you can also earth ground the negative of this cap bank, and it will establish a reference point and more rapidly recharge the system without draining your input source. So that's that. And we'll take a look under the desk. Absolutely nothing. I'm going to put this thing portable soon, move it around. It's a lot smaller, simpler, more refined than the big transmitter system. Take a look over here. There's absolutely nothing. So I'm showing you guys literally everything. It's not much to the circuit. It just goes through different stages. Maybe where a lot of people went wrong is they didn't spend enough money on a big enough cap bank. That's about $200 or $300 right there in caps. That stores the power, because we're essentially generating a high frequency, high voltage through our circuit here, which gives off a little bit of wireless power. It powers up the ringer circuit, 1 or 2 watts. We then take that high frequency power, goes through a very efficient bridge rectifier made out of Scotty diodes. That output charges up a huge capacitor bank, so we have very high voltage, no current right now. But the large capacitor bank turns that high potential into real energy that can do work. And if you earth ground one end, you establish a reference point and it will recharge even quicker. So you're turning your very high voltage, no potential into a source of real power by storing it in the big cap bank. And then from that cap bank, it goes through a timing circuit. You need the timing circuit. And it goes through the reducing circuit. So we take that 50 or 60 volts DC, and then we pulse discharge it at 0.1 second every 2 seconds. And it's discharging maybe 5 or 10 amps at 14 volts. And that bulb almost looks like it wants to burst. And once you get the timing right, there is no form of degradation on your input. And with this circuit, you have more output over time than your input. If you calculate how much power this is in this, how much power is in that pulse versus how much you're inputting, your output is higher than your input with respect to time, if you account in the time factor. And then again, you would take that output, you would dump that into a battery or another super cap. These were Brazilian where I got these. You can get big audio caps too that work. Certain capacitors respond better to the pulse. You want something that recharges very quick, that can recharge very quick and discharge quick. You would then take that output that's running the bulb, dump it into your big cap or special battery, and then you run your inverter. You're off running. It's literally that easy. And that pulse fights the voltage drop of your load, and it will keep your cap recharged. So I'm showing you that's the capacitor itself, the raw capacitor, or storage, the pulsed output running just a bulb. I could even hook up a motor, but I'd probably break the motor. I think I will hook it up just for the hell of it. If I can find it. I don't remember where I put it. Nah, it's probably gonna blast the motor off the table if I did that, but maybe I should. Certainly would be entertaining. Screw it, I think I will. Oh no, it's gonna make pure chaos. I had a motor mounted to a little metal stand. I'm gonna see if I can find it. Can't remember where I put that thing. And I'm doing this video live, no cuts, so no one can say anything. Because I have a lot of skeptics, and they're really starting to annoy me, to be honest. So, where did I put that motor? The moment I shut the video off, I'm gonna find it. I'll look for it for another minute, and then I'll stop. Not seeing it. Anyway, you get the idea. I'll even try and put that dumped power into a very large bulb here. I can't find that little motor, but this is I don't even know what that is. I'll read it to you. It is a 120 volt, 100 watt mini heat light. Now I'll hook that up, and it still shouldn't drain our input because we have the timing correct on the super caps. I mean, not the super cap, on the cap bank. You might not even see that activate because it's 120 volts. Yeah, you can't even see that activate. Voltage is too low. That's a 14 volt pulse at like 10 amps. but it certainly likes the automotive bulb. If I could hook up that motor, you'd really see it take off. I'm going to really try and find that motor. It's not far. Oh, I found it. This is what it is. I'm going to hook this up now. Little thing's probably going to take off. Now, can you imagine if you had this output going to a huge motor generator type of arrangement? That would probably still yield you power too. So, now I will hook this up. This thing's probably going to take off. I think that... Oh, you know, I did kind of burn this one out. Yeah, this one's almost short-circuited inside. It's not working correctly. Damn. I swear, you gotta do a video, everything goes wrong. But I hooked this thing up to too much power and something in it got screwed up. I forgot that happened. Some of the windings internally shorted out a little bit in that thing. But anyway, that's an incandescent bulb. We can fully see the work that's occurring within it. So, and again, there's our input. So, hopefully this answers some questions. And you can see clearly what's occurring and going on, because this stage, we're at the third stage. We're almost at the second to last stage. That output then gets dumped into the supercapper battery, that then runs the inverter. So I'm just showing you that we're taking the raw output from these caps through the timing circuit, and that's what it can do. Yep, and again, I'll sum it up. Input cap passing through an analog meter so we can see the current draw. Goes into a voltage reducer because that's a 14 volt DC cap. Reduces to 9 volts. Powers up the ringer or the pulsar circuit, whatever you want to call it. Less than 1 or 2 watt draw. It energizes the circuitry. We're hardly using any input to create a high voltage, high frequency potential. That high frequency, high voltage potential with almost no current gets rectified to DC via our high frequency, high speed Scotty diodes. Builds up a rapid charge because it's high frequency in our big capacitor bank. And if you negatively earth ground that capacitor bank, you establish a reference point and it recharges quicker with no input drain on the source. You then have to use this power in pulses. Very important, you have to use it in the correct timed pulse. Failing to do so will put a large drain on the input of your circuit and negate your free energy gain. So that's very important. You need the timing circuit. It's a pulse. Everything in nature has a pulse or a beat to it that's alive. So I'm explaining it to you very simply. Then you take that pulsed output and you're in business. You dump that pulsed output into your big 12 or 14 volt storage medium that then powers up your inverter and runs whatever you want. You're off running and you have more power over time than what you're spending on the input. You can accumulate more power in big battery banks or big capacitor banks that then run your inverter, or you can just store it in batteries. And then you can take that power, keep the input fully recharged, have excess, do whatever you want with it. And the excess power is coming from two sources. The two sources are the negative ground potential when we ground this, because the earth itself is becoming part of the circuit. And the other source is this thing, the exotic core material, the nano crystalline ferrite core, which has trace amounts of metglas in it. So this device itself, we're extracting power from via the ambient environment. It's interacting with the environment somehow and the earth. So that's that. I explained everything. Full science nerd mode. That was a mouthful. And there's the system. There's nothing under the desks. This thing will be portable soon. It's already kind of portable, I just gotta clean up the wiring more. It's gonna be mounted on a board, and it'll be doing some cool things. And I bet you if I even put 2 of these lights in parallel, that pulsed output could still run it no problem, full intensity. Still put no drain on the input. Because once you calculate the correct timing, you're in business. So that's that. Feel free to like, comment, subscribe. Join our Patreon. Even if you're not a paid member, we still have an archive of a massive amount of electrical engineering information, all compiled in one spot. You don't have to spend hours searching different sources. It's all compiled in one spot for simplicity on the Patreon. And yeah, thank you to all the loyal supporters. A deep thank you to everyone. I just know there's going to be skeptics out there. Here's a super cap. Extremely light. A lot lighter than a traditional battery. Which is right here. If I can grab it without knocking anything down. So, super cap. Battery. Much heavier. As you see, it can easily lift up, move. It's extremely lightweight. We have extreme power. That's a bit heavy and chunky. Got this thing. I don't really like lifting this up, but you can clearly see under it, so can't have anyone say anything in this video. So, this is a debunk video, proving to you the concepts, the theories, and the points, how the timing circuitry is so important. So, that's that, and thank you, everybody.